patent of the problem and solution. When he was young, he is a patent officer. Okay, patent officer. Okay, I just write down here. I think you know about this, huh? Patent. Or pronounced as patent, all right? So he's a patent officer. He read the patent and he recommend to his boss those who can be patented. So he found out, he found out the problem that people come up and the solution when people created is similar. So he's the one who studied the patent. Then he synthesized down to the innovative patent. And this innovative patent here, for 40,000, he synthesized to come up with the 40 inventive principle. This is a solution, one of the solutions is called what? Merging. Remember, just now on the first two slides, I'm talking about merging. And this merging is a concept of combining. And this guy, Jerris Altshuler, he found the pattern, the solution come from others people, is a similar. So that's why he came up this solution from 40,000 patterns. So I share with you later what are the 40 inventive principles. Of course, due to the time concern, I cannot able to explain to you all. And then in the future, maybe we have at least about 2 days, then we can learn about this more. At the same time, he come up with a technology trend, and also some scientific effect to solve the problem. So today we will concentrate on this area. Just now he mentioned about the words called problem and solution were repeated across industry and sciences. Everyone agree about this statement? Is it a problem and solution always repeated across industry and sciences? Okay, maybe we look at this case. This is a bell pepper. All right. So are you cooking every day? I mean, you cook every day? Do you cook? You like to cook? Anas, you like cooking?
Yes, sir. Yes, sir. I love cooking.
I thought your girlfriend will cook for you. No, you cook for your girlfriend,
Good for wife.
Okay, right? You like cooking, So you know bell pepper, right? Bell pepper,
Yes, sir.
Okay. So this one is bell pepper. So this, how you cut the bell pepper? It's just like this, using a knife to remove the core. Okay, am I right? But if you want to remove the core from millions of this bell pepper, how to do it? If you want to remove the core from the millions of bell pepper, how to do it? You cannot cut by using a knife. You have to put it here. This is a pressure cooker. So you put the air inside. All right? Then you force the air inside. And then you suddenly release it. Then the core will come up. So this is patented, near 1945. Oh, I think you haven't born yet. I think all of us haven't born yet. All right. So year 1945 is a patent for processing the bell pepper. What are these generic solution? Slowly raise the pressure and suddenly reduce it. Okay, force the air inside the bell pepper, suddenly reduce the pressure. So everything will come out from the bell pepper. So this is a solution. Slowly raise the pressure and suddenly reduce it. So this is very important. Okay, this is year 1945. Now, do you know about this? How you remove the shell from the nuts? How you remove it? The shell from the nuts. This one you can use hand, right? Just a little you can use hand. But how about if you want to remove millions of this, the millions of this? So you put the water inside. Same again, using pressure cooker. You force the water inside. Sudden release. Shell will come up. Only the difference is what? This is water and this is air. Patented in the year 1950. Removing the shell from the nuts. You see the same solution. Slowly raise the pressure and suddenly reduce it. It's exactly the same. So, problem and solution repeated across industry and sciences. 27 years later, how would you break the artificial diamond? Anyone can tell me, how would you break the artificial diamond? In the year 1972, patent had been done, and the diamond are placed into the pressure chamber. High pressure force the air in the microfracture, release the pressure, and break diamond into the crystal. So the same solution principle was applied. Year 1945, year 1950, year 72. Same again. They got many applications. The pattern is what? Raise the pressure and suddenly release it. Removing the core from bell pepper. Removing the shell from sunflower seed. Many. Make the diamond into the micro crack, producing a sugar powder. So, can I prove that problem and solution were always repeated across industry and sciences? So now, agree? So if you want to come up with a solution, do you really need to come from the initial stage? I don't think so. You can learn from the pattern of the people, what they have done. So that's why the Altshuler came up with the 40 inventive principle from those patterns. Why trees? Why trees? Long time ago, we are using try and error problem solving approach. We want to solve the problem. Okay, when the boss asks you a question. No. When the boss asks you a solution, what you do? Normally, you will come up with a solution based on experience. Do you really sit down together with your team and go through a problem-solving process and come up with the answer? Or you just based on the experience to tell them an answer? So these are very important. So we cannot try and error anymore. Do you know this guy? Do you know this guy? Edison? I think all of you know this. So he's the one who come up with the light bulb. Okay. So you know in the year 1879, he's spending about 40,000 and performing the 1,200 experiment with a 5,000 researcher. Am I right? Wow, a lot of resources have been used. You know why? Do you know why? Because he is using try and error problem solving approach. Now, you all are the lecturer or you are the students. Then you will talk to the principal. Principal, can you give me 40,000? Can you let me to do 1,200 experiment? Can you give me 5,000 researcher? Can you request these resources from the principal? I don't think so, right? So because you cannot use try and error anymore. We have to come up what? We have to come up with the systematic way of problem solving. So we cannot just, try and error anymore. We have to use a structure and a systematic problem solving method in order to increase the efficiency and also the speed of innovation. So look at the trees. Trees has actually been applied in many years. Okay, so I'm very happy to share with you about trees today. Okay, and I do share with some of you last few years, and I hope that you can learn more, all right, with these trees. And then the trees is actually really famous in many industry like Boeing, IBM, Motorola, Xerox, and the HP, and also Samsung recently as well in Samsung. Many years, actually many years. Like a Samsung, the new model of the handphone, they are using trees. So because I know the trees consultant, trees master in from Russian, and then they come to Malaysia before, they are actually the consultant for Samsung. So we do have a sharing with them about how trees is actually implemented in Samsung. So of course, as you know, maybe you have heard about the brand called Vivo. Is it Vivo in India? This brand handphone? Is it in India? VIVO?
Yes, sir. We use the Vivo products. Yes, sir.
Yes. This product, I think they also have a trees inside the Vivo as well. Vivo company. All right. So they got many. Not only all these company I mentioned to you, but many. All right. So again, this is a structured way of a process and the best practices. I think many of you heard about Lean Six Sigma, Lean manufacturing, all right, all these best practices. So you can combine together with this. Not only about the Six Sigma, we can use trees as well. Six Sigma more on the statistical process. They are more on the data analysis. How about the problem solving side? Maybe you can use trees. You can use trees. And more reliable and repeatable for this. Okay, maybe we go through with you about inventive principle. So I've shared with you about inventive principle. As I mentioned to you just now, Alschuler screened 200,000 patents to find out what kind of contradiction were resolved by each invention. So he has studied about 200,000 patents, from outside, from worldwide. And then he found that inside the pattern, they have a contradiction. Contradiction in terms of when you want to solve a problem, they will face a contradiction. Is that right? Face a contradiction. When they are faced a contradiction, then people will come up with the solution. And then this solution, Generis Alschuler, he captured it and then put inside as 40 inventive principle. This is a solution. All right, this is a solution. So look at this 40 inventive principle. Start from number 1, segmentation. Segmentation. Second one, taking out local quality, asymmetry, merging, university, nested dog, anti-weight. They got many, until composite material. Maybe which one you like it. You can have a very quick look, 1 second, to see which inventive principle. Later, I will go through with you with some of the inventive principle, and then I will share with you how you solve the problem by using inventive principle. Okay? All right. So I think some of the terms you are quite familiar as well. So let us review the first inventive principle. Segmentation. What is meant by segmentation? Anyone can tell me what is meant by segmentation? Segmentation is divide the object into the independent parts and make the object become easy assembly or disassembly. All right, I think you know about this company called IKEA. Is it in India? IKEA, is it in India? Is it in India? Anyone can answer me? IKEA?
Yes, sir. It's there, sir.
Okay, good. Okay, thanks, Anas. So is it pronounced as IKEA? Is the same as India as well? Same pronunciation?
IKEA.
IKEA, yeah. Some country, the pronunciation is different. So in Malaysia, we pronounce as IKEA. And maybe in your country, pronounce IKEA or, okay, whatever Kia. Okay. All right. So this is the company whereby they are solving the problem. How they solve a problem? Okay. You know why? Because they say that, hey, I want to sell a furniture, but I don't want to, some small furniture. I don't want to spend my time to transport this furniture to my client, to my customer. All right. So what you need to do? So he think about, hey, why not? I just make it DIY. DIY mean by what? Do it yourself. All right. DIY mean by do it yourself. All right. So do it yourself is mean by you have to segmentize it. Okay. So you have to segmentize it and make it into the smaller. Break into the small team, virtual office, something like a concept of this furniture, break into the small piece. Then they want to carry very easy. Once they bought it, then they can carry by themselves. Okay, flexible. So this is a way to solve the IKEA problem. IKEA problem. So it's segmentation, segmentizing. Have you seen this product before? Camping Tank. They do a segmentation. How about the Lego block? Same. Do a segmentation. You want to break into the small pieces, or you can do the assembly. Same with this assembly and this assembly. 3D puzzle. And also your conveyor system. Your conveyor system. Am I right? Your conveyor system. So your conveyor system is actually can be assembly and can be disassembly. Okay, how about in terms of management? I think today conference, not only engineering, maybe can talk about management. Wow, very interesting. Actually, my doctorate is in engineering business management. Actually, I was an engineer before. I like engineering, but after that, I also found that I also like management. So that's why I study my engineering business management. So in terms of segmentation, also one of the segmentation called inventive principle. Okay, divided the difficult problem into the smaller segment for better focus. Market segmentation. Okay, I think some of the students using this principle before in solving their problem as well, especially doing assignment. When you do the group assignment, is it you divided into the many parts? Part 1, okay, friend, part 1 you do it. Part 2 you do it. Part 3 you do it. Part 4 you do it. Part 5 you do it. Then after that we combine. Then become one assignment. This is the way you are solving the problem by using segmentation. Segmentation. Okay, principle number 2. Extraction, taking out. Extraction, taking out. Principle number 2. Something that is no good, you can take out. Something that is no good, you can take out. You see, this one is a tooth. You got your tooth pain. Are you going to take out or just leave it there? Sure, you take out, isn't it? So this is one of the solving problem solution. Solution for solving this problem. How about this one? Air compressor unit. Normally you put it outside or put it inside. Air compressor unit. Outside or inside? It's actually outside, right? Because air compressor is very hot. You cannot put inside the room. So you just, have to put it outside. So this is called taking out. All right. So taking out can be many ways. Many ways. So this is a concept for you. All right. You move a person to the area where the person's strength can be fully utilized. Also, you call taking out. Maybe some lecturer, they are not good in this subject. You can think about it, move it to his strength. So it's called taking out. All right. Terminate the employee, terminate the contract. Also one of the solutions. Take away the restaurant. Take away. I think now, due to this pandemic, right? COVID-19. So we are not able to have a good dinner in the restaurant. We have to take away. So take away also one of the solution solved in this pandemic. Okay. Quarantine also one of the way. It's called taking up and then put inside one area. Take away part of the business process and outsource it. Sometimes maybe the business is too big. You are not able to employ a lot of employees. What you do? You outsource it. So this is a principle called taking out. Local quality. Ladies and gentlemen, can you see this is the pencil with the eraser? Yes, you can write. At the same time, you can erase. Local quality. This one is a hammer. You can hit the nail and you also can pull out the nail. So this is called local quality. Local quality. So sometimes the product have a local quality. All right. So for example, in some area, you have a fun room. Okay, just say right now you went to McDonald's before. McDonald's, huh? So this McDonald's, you have a kids area. Is it the playground in the restaurant? Kids area in McDonald's. So this is a way whereby they generate a local quality. How about this pantry area in the office? Yeah, so some of the office, they have this area whereby you can make a coffee, share your information, chit chat or whatever. This is called local quality. All right. So it's principle number 3. How about principle number 4? Asymmetry. Asymmetry, not symmetry. From symmetry to become asymmetry. From asymmetry to become symmetry. All right, now look at this design. Is it symmetry? How about this one? Hey, this one, not symmetry, asymmetry. Hey, quite nice as well, huh? If not symmetry, huh? All right. How about this one? Symmetry. How about this one? Hey, asymmetry. This one, all symmetry. How about this one? Eh? The design is the asymmetry. This one is symmetry. But this one not symmetry because it's too stressed. The face distorted. Face distorted. So asymmetry. So sometimes you can make the things asymmetry to symmetrical or from symmetrical to asymmetrical. So always engineer. People always say engineer always what? Always, very symmetrical. So, but we can change, sometimes from symmetrical to asymmetrical. Okay, clear? Merging. I think this one you've seen before, this merging. Merging mean by what? Merge together. Now, okay, if not enough toilet, how you solve the problem? If not enough toilet, okay, you have 2 toilet right now. One is for the male, one is for the female. Okay, normally for the female, they have to wait, because it's a long queue, because they take times to go to toilet. How about the male? No, maybe two person only waiting, very fast. So how to solve the problem? Maybe we can merge together. Male and female, everyone also can use. Male and female. Everyone also can use. Then you can, no need to queue up so long. Everyone is equal. So this is a way to solve the problem. Okay? And also you have this problem in your university. Sometimes you have a big room. Okay? But your room is not enough. So what you need to do, you put a partition. When you put a partition, you can make it bigger or you can make it smaller. So if you remove the partition, means that you are merging 2 rooms become 1. 2 become 1. 2 in 1. All right? So if you want to make it 1 to 2, it's called segmentation. 2 rooms become 1 room. Then you can occupy more people. So this is 1 to 2. Okay? Is that all right? So this is called merging. Okay. Any question? Okay. So now merging can be merged together. Okay. Combine the team member together and make it move the boat faster. This is called merging concept. Merge together. Combine the team member with a similar competency to solve the problem. Okay, all this about merging, merge together. Is that right? Package holiday, also merging. Okay, for example, now you want to come to Malaysia. Okay, welcome to Malaysia. Okay, maybe you don't want to just only come to Malaysia only, right? You will go to Thailand at the same time. And also you will go to Singapore. So why not in your holiday, you just make it 3 3-in-1 package. Merge all these three together in one holiday. So this is called merging concept. Merging. All right? Is that okay for you? So what is the opposite of merging? It's a segmentation. Universality, multifunction. I think you can come up with the multifunction products. This car safety seat can convert into the carry-on basket. This van with the many bed, kitchen, and sofa. Camper van. Inside there, they got multifunction. Can sleep, can cook, can relax. All right? And the smartphone, PDA, GPS, camera, Wi-Fi. Is it multifunction? Yes, multifunction. All right? How about this toilet seat with a heated seat with the auto water jet? Photocopy machine. Now you can print, you can scan, you can fax. This is called multifunction. So think about it. You want to create some multifunction products in your university. Think about it, multifunction. It's very important inventive principle. Nested door. Nested door is also one of the good inventive principle to solve the problem. I do not know whether you have seen these toys before. Have you played this before? Anyone? Have you played this before? Anyone played this before?
Yes, sir. Yes, sir.
Oh, very good, very good. Okay, so this is called nested door. Okay, this is a small one can go inside this. And this one can go inside here. And they are hollow, you know, hollow. And this one, they go inside here. And this one, they go inside here. And this one, they go inside here. And this one, they go inside here, become only one. So everything is inside. So it's called nested door. So this concept is from, this door is from where, you know? Russian. So you're using this concept to put everything in one. So that's why you see, they come up with this stand. You want to make it longer for you to take a photo. You want to make it shorter for you, easy to carry. So they are solving the problem. Because initially, you have a very long, but it cannot be nested. So how you do it? You cannot carry easily. You just carry the long stand all around the world. Cannot. So finally, they come up with this concept. Nested door. Same with this cup. Everything can put in one. And antenna as well. Okay, this one can make it shorter for you to bring. This one can make it longer for you to teach. They are solving contradiction. Solving contradiction problem. Same with this also. This luggage. Now, next time you come to Malaysia, all this luggage, you put inside here, inside. And then only one. And then you carry to Malaysia. Malaysia, Thailand, and Singapore. So after you go back, wow, everything is open. Everything is open, and then you put a lot of things inside it. So they are using the nested door concept. So think about it. Some solution can use nested door to solve the problem. I go through together with Intel in Penang, in Malaysia. So this is a big company in Malaysia. So the engineer actually solving this problem by using this inventive principle in one of their case study. Principle number 8, counter or anti-weight. Counter or anti-weight. What is meant by counter or anti-weight? Make the weight become lower. For example, this is a banner. This is an advertisement banner. So you want to make this advertisement banner to raise to the very high and let people see what is happening. All right. So then this what we call the helium balloon is actually helping them to do it. It's actually reduce the weight. So this helium balloon is an anti-weight solution. Same with the car. Okay. And also one of the problem happened into the cable. One of the cable actually fall inside the river. Okay, fall into the river. And then the helium balloon actually used to hang, temporary hand, suspend all this cable, and then they are safe by using helium balloon. Why you have to use this design, aerodynamic design? Because this is an anti-weight. You are not going to design a car like this, right? Isn't it? Isn't it? You are designing the car like this, right? Okay, sorry. This is a car. Okay. Okay. All right. Aerodynamic. Am I right? Aerodynamic, isn't it? So this is very important, like a plate, aerodynamic. Dynamization. What's mean dynamization? Flexible is called dynamization. Flexible. So you can see that expandable table. Again, can be flexible. You want to become small, then for less people. You want to become big for many people. So it's a dynamization. Now, foldable bicycle. Dynamization. So I already mentioned to you, you got one trees master consultant is doing the dynamization for handphone. Samsung have came up with a new foldable handphone. Is that right? So this is one of the concepts called dynamization. You want to make it smaller or you want to make it bigger. Dynamize mean by what? Make it flexible. Dynamic mean by flexible. All right? Static is not moving. Dynamic is moving. I think you studied this before. Continuity of useful action. You make it, the good things always happen. Always happen. So this is a fitness center. Are you going to reduce your weight? Continuity or maybe sometime? Always go it or you just go sometime only? Of course, you have to always go it. Continue for the useful action. Okay? Intermediately. Now, this is very important. Sometimes you can solve the problem by using intermediately. Okay, for example, this is very hot. Now, how you solve this problem? You have to use a cloth as an intermediately. Okay, this is very hot also. Now, it's from McDonald's, hot coffee or Starbucks. So you have an extra intermediately. How about this one? It also is an intermediary. It's not going to erase it, isn't it? It's an intermediary. Correction paper. Like counseling, facilitator, using a third party during difficult negotiation, the coach, the consultant is actually called intermediary. Intermediate. Okay? Now, maybe you have gone through the inventive principle. I think about 10 or 15 inventive principle. So maybe I want you to have a quick exercise just to let me know what are the inventive principle inside there. Okay. Before we start, any question from the participant? I think Danush. Is it Danush?
Yes, sir. Yes, sir. Danush?
Yes. Danush, anything want to ask me?
I think he left. I think, sir.
All right. Okay. No problem. Okay, now, can you just spend about 1 minute to just match this one to me? Okay, just say this is what? Oh, okay, I just simply write, Okay, just like that. Okay, just tell me what are the answer. Okay, this is not the right answer, Okay. So, can you just match? Okay, I give you about 1 minute. Start from now. So, you have 30 seconds. Okay, last 10 seconds. Okay, so done. Okay, what is the first one? What is the first answer? You can write down the checkbox you want to. What is the first one? Okay, the first one I write down here is what is the answer? You can write down the checkbox as well. Don't be shy. This is number 1. This is number 2. This is number 3. You can write down the answer right now. Just write down 1 is what, 2, what is the answer, 3, what is the answer, and also on. 1, 2, 3, 4, 5, 6. Okay, you can write down, then at least I can tell you the answer. Okay, very good, very good. So the first one is the nested door. All right, very good. How about the second one? How the second one? Anyone to try? Second one is a must, actually. Second one, what is the answer? Intermediately, intermediately. Okay, how about the third one? The third one, what is the answer? Anas, you want to try? Anas is here. What's the answer? Antiweight. Antiweight, because it's floating. All right. How about this one? This one is merging. This is merging because this is a bicycle lock. Car park, bicycle lock, bicycle park. So can lock the bicycle as well. So they are repeating. Repeating mean by what? The same thing that happened. So they are merging together. This is a cake. So you cut the cake. Segmentation. You cut the cake and then give to all the students. Segmentation. How about this one? What is this one? This is the okay, asymmetry. Because normally the lens is in the middle, but they are put it on the one side, asymmetry. You might also can give me the answer for nested door. Because this one can be go inside and can be come out. So this is called nested door. Sorry about that. This is called nested door. Okay, clear? All right, so this is the answer for inventive principle. So you can see that today you have learned about products and inventive principle. If you look back again with the product around you, actually they got a lot of inventive principle. When you have time, you can go through about 40 inventive principle. Okay, so maybe we can go through a case study on Coca-Cola bottle. All right, how actually Coca-Cola can come up with a very innovative products and also how to come up with a solution to solve the problem. Okay, may I know in India, is it what type of the bottle you use in India? Is it using a plastic or using the glass or using the aluminum can? Any product actually you use in the as Coca-Cola? Any?
We used in a plastic bottle, sir.
Oh, plastic. Yeah? I see.
Yeah, plastic.
How about the glass? Do you use glass?
Yes, sir. It is available somewhere
It
in
is,
glass and aluminum tin also.
Oh, okay. Thank you, Dr. Balakrishna as well. Oh, is some using glass. But in Malaysia now, no more glass. So, but I love glass. When I was young, I used to drink with glass. So I love glass. I think you also the same, Dr. Balakrishna, you also would like to use glass as well. But they are more expensive, right? If a glass, am I right?
Sir, yes, actually, yes.
Yeah. During our New Year time, Chinese New Year, we used to drink with the glass. We are using the very, very heavy. That's why, so people want to take to you and sell to you. They are quite, the weight is quite heavy. So I think Now they are using a plastic and can. I don't know whether you tried before using ice in India. Ice. Have you seen using ice? This is
I'm not
made of
sure, sir. I'm not
ice.
sure actually where the people are using this kind of
Huh?
ice. Yes.
You tried before?
No, I haven't.
You haven't, huh?
Yes,
Okay.
I haven't.
Yeah, this is another innovation way of doing things. So people like to drink a very, very cold Coca-Cola. So they come up with the ice. What inventive principle they are using? Homogeneity, uniformity. Homogeneity mean by what? Same material. Same material. Okay? It's an inventive principle 33. Inventive principle 33. So today I don't have time to explain to you further. That's why now I show you how they actually using inventive principle called uniformity. Okay, for example, I give you an example for homogeneity. Can you tell me what are the hardest materials in the world? What are the hardest materials in the world? Anyone can tell me?
Diamond?
Yeah, right. Thank you. So how you cut diamond? How you cut diamond?
By another diamond?
Also using diamond, right? So
Yes.
diamond cut diamond. So means that you are using homogeneity material to solve the problem. Same with this as well. So they are using ice. Okay, but the problem is what? They are difficult. They come up with another problem. They are difficult to hold it. They are difficult to hold it. So can you tell me how you solve the problem? They are difficult to hold it. Difficult to hold because it's too cold for them to hold it. But it's good to drink, it's good to drink because it's nice. You see, when you come up with a product, you have a contradiction. You have another problem, secondary problem. So I make it as a problem called if I use ice, then very nice for me to drink, but difficult to hold. So this is a problem. How you solve this problem? So maybe I will show you the video. Can you look at the video? Then you tell me what is the problem. What are the solution? You tell me what are the solution they use. Okay? Let's see the video now. Coca-Cola has satisfied our thirst every. Can you see the video? Can you see the video?
Yes, professor. It is playing
Okay,
now.
so I play again. Okay.
Yes.
Coca-Cola has satisfied our thirst every summer since 1886. So how can Coca-Cola stay so refreshing? By creating the real ice-cold Coca-Cola.